Hey, all, today we are going to start talking about one of my favorite shapes, circles. And we're going to start with discussion of angles and arcs that are created in circles. So the first thing to talk about are arcs. This might be something new to us, what an arc is. An arc is just a piece of a circle. And so we know what angles are. So if we look at this circle, we have this angle inside it, LQK. And if you remember when we were naming angles, it was a bit of a roadmap. It tells us to start at L, go to Q, and stop at K. So we're talking about this angle right here. And this vertex of my angle also happens to be the center of the circle. And so when it comes to circles, when I have an angle whose vertex is at the center, we call this thing a central angle. And you can see up here that we want to talk about central angles. So a central angle is a circle or is an angle whose vertex is at the center. And as you may or may not have noticed, the name of the lesson is about vertex at the center. So these angles intercept arcs. Intercept, you can think of when we have a y-intercept or an x-intercept. It was a place where a line crosses the y-axis or crosses the x-axis. And so our angles intercept arcs. They cross over our circle. And in this case, when we have an angle, it crosses over in two places. So you can see there are two places where my angle is going to touch my circle. And so when it crosses or touches my circle, it creates an arc. And an arc is just a piece of that circle. And so the first thing we need to know is how to name these arcs. When we name an arc, it's similar to naming an angle. It's telling us where we start and where we end. So if we were to take a journey on this arc, this green arc, we would start at L and we would go to K. And then to let somebody reading this know we're talking about an arc, we put a arc on top. So this reads arc LK. And this happens to be what we call a minor arc because it's less than 180 degrees. So this is a good time to mention that a whole circle, the whole circle is 360 degrees. And so that means half of a circle, which we call a semicircle, is 180 degrees. And that's not how you spell circle. And so a minor arc is less than half of the circle. So if we were to go around this entire circle, that's 360 degrees. That's like you standing in place and then spinning around completely. A semicircle is going halfway, half of the circle, and a minor arc is going to be less than 180. So when we're writing the name of a minor arc, we're going to use two letters just like this. So you might guess from looking here and from the fact we named something a minor arc that there's something called a major arc. And a major arc is greater than 180. Of course, any arc needs to be 360 or less. So if I talk about an arc that's 360 degrees, that's the whole circle. So if I were to want the major arc for this angle IQK, first I'm going to find IQK. I'm going to start at I, go to Q, stop at K. The major arc would be the arc that's formed that's more than half of the circle. So there's two arcs that get formed here. There's this one, and then there is this one. And I hope we can all agree that this yellow arc, this yellow piece of the circle, formed by I and K touching the circle, is larger than this pink one. The yellow arc is going to be our major arc associated with this angle. And so we would write directions. We would want to tell somebody reading this, where did we start to create this arc? Well, we started at point I. And then we are going to have three letters when we have a major arc. It's going to tell us which direction to go, because I can start at point I and go follow the yellow path or follow the pink path, but I want to follow the yellow one. So I'm going to tell the person reading this, I want to go towards letter J. And then I'll continue following my arc until I end at letter K, and then I'm going to put an arc on top. And so this tells us our journey. We could go the opposite way. We could start at K and go towards J and end at I. In both cases, it tells us the beginning and end of the arc, and it tells us which direction to go. That middle letter tells us which direction we need to go. So we can do the opposite. We can find arcs by following directions. Here tells us to start at G and go to H. And since there's no middle letter, then our arc should be something less than half the circle. So I wouldn't want to go around this way. That would be more than half. And so then we can trace the angle that creates that arc. That's this angle. And so we could call that angle HQG or angle GQH. Either way, that point in the middle, my vertex, my center here, because it's a central angle, is Q. Similarly, we're going to look at the names of this arc, and it's a roadmap. It's telling us to start at F, start our journey at F, and then go towards E, and we're going to stop at G. So if I'm going to stop at G and go towards E, I must go this way. And my major arc, and I really recommend you drawing the circles and then maybe doing some of these tracings or squigglings just to show you which arc you're looking at. And that's going to be formed by this angle right here. That's angle FQG, or you can call it angle GQF. Both are the same. I think it's really important to draw these pictures and to use either colored pencils, markers, use a pencil and darken in, but show yourself what arc you're talking about. So now that we know how to name these things, we need to know the relationship that exists between them. Central angles, if I measure a central angle in degrees, it's going to be the same degree measure as the arc it intercepts. So I would say the angle is equal to the arc. I might put a C there for like central angle. So I want to know the measure of my angle WTX. That's this angle. And so I don't know what its arc is, but I do know that this angle should be the same as this one. And in fact, I'm going to walk this back a little bit and simplify to start. Let's not find WTX. We have this arc here labeled 67 degrees, and it's intercepted by this angle here, UTV. And so let's find UTV. Well, since the arc that this angle intercepts is 67 degrees, that means that this angle is going to be the same measure. And so it's going to be 67 degrees. So when I have an angle inside of a circle and its vertex is at the center and it's a central angle, then the measure of the angle and the measure of the arc it intercepts will be equal. So let me look over here. I'm going to ignore this. And I'm going to say, I want to find the measure of the central angle associated with this arc. That's 140. And so that's this angle, WYV. And since this is a central angle, its vertex is at the center. Then that means this angle is just as big as this arc. And so we can say that this angle is 140 degrees. So we can use this information to now do maybe some more complicated problems or problems that take a couple steps. So I want to know the measure of WU. That's going to be a minor arc between W and U, less than 180. So our answer should be less than 180 degrees. And so we can use this information we have. This central angle makes this arc. And so this one should be 100 because they should be the same. This central angle makes this arc. And so this one's 125 because they should be the same, because they're central angles at the vertex. And so what I said at the beginning of the lesson was the whole circle is 360 degrees. And so you can see my blue arc, my orange arc, and my green arc. If I put them all together, they make the whole circle. So I'm just going to subtract 360 minus 100 and then minus 125. And I can figure out how big my blue arc is. So we're sort of combining some ideas here. Central angles, the whole circle is 360. And so I'm going to get 260, 160, 135. So this arc is 135, and this angle is 135. So this does take some problem solving, and so we should always just work this out step by step. One thing I always advise is if you have a piece of information, see what it will tell you about the picture. So I know that this angle is 100. That means that this arc it makes is 100. And look, learning is sloppy, so sometimes this can get sloppy. This angle is 101. That arc is 101. That angle is 41. That arc is 41. These are all central angles. This angle is 67. That makes this arc 67. And we want to know BEC. That means to start at B, go towards E, and stop at C. So we want to know, hey, how long is this whole big arc? The only thing we're missing here is the purple piece. This arc is almost the whole circle except for the purple piece. And so I know that this arc is 41 because I use my knowledge of central angles to say, hey, that one's got to be the same. So my whole circle, or my yellow arc, is my whole circle minus this purple piece. So I'm going to say 360 minus 41 gives me 319 degrees. So my yellow arc is 319 degrees. And I found that answer just by starting to put things onto the picture that I know because of central angles and some of the stuff that was already labeled. These things take practice. So do make sure if you got stuck here at any point, ask one of us for some help. Do make sure you do the problems at the end here. And if you need help with those, that you ask one of us for help. And almost more importantly than anything, make sure that you go and do some practice on this stuff. The more you practice it, the more you start to see things pop out and the easier these problems come. So take your time on these and good luck.